Hey everybody, this is Larry. This is try two for trying to get a problem that I haven't done before. Earlier we did get an SQL problem and I did solve it, but obviously it's a little bit awkward. Oh, okay. So let's look at this one. 1187, make array strictly increasing. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So let's see. So given two arrays, I haven't done this one, right? Yeah, I don't think so. But it feels like it's reads like something I should have done before, or could have done before, but don't remember. Anyway, okay, so you have two arrays. Return the minimum number of operations needed to. What is an operation? You could choose I and J. So basically, you could steal an I and a J. Can we do a swap, or is this? Oh no. Okay, so it's not a swap. It is just that you can do it. Okay. Okay, they both end is 2000. I mean, this my first intuition is just gonna be DP, just because these things with decisions, maybe we can figure out a way to be maybe we can figure out a way to just maybe we can figure out a way to be exhaustive search, right? So that's why I was thinking about dynamic programming. And you go to 2000 kind of confirms that for me a little bit, or at least it's a possibility. Not that it is dynamic programming. We have to kind of see. The second thing is that all the elements are 10 to the 9, meaning that, well, you can't do anything funky like linear search or something like this. That said, it doesn't stop you from linear sorting. Sorry, I don't know if I said linear search or I don't remember. But that said, because n is the only goes to 2000, it doesn't stop you from doing re-indexing or renormalization, basically coordinate compression type thing, to kind of get like the relatively ranks and stuff. One thing I would say is that the order of R2 doesn't actually matter, right? Because you don't have to give response or anything like this. So the first thing I'm going to do is sort R2. And why do I want to sort it is because now now it allows me to maybe do either. It just it gives me a better structure to work with, right? Because now I can sort, I already sorted, but I could binary search on it. I can, do a walking up. There's more greedy ways and so forth. And because now, you can almost think about it as an implicit thing. I don't know if it's needed for this problem, but you can say that because it's sorted, you can also, instead of keeping track of which element is used individually, you can now say all the elements smaller than x is used, right? So now you can represent all the used things with one index, roughly speaking. I mean, I don't know if I explained that right. Okay. Beyond that, let's see, right? So then here, I'm trying to think. So I think I have an idea on how to do it, but but I'm also just trying to think whether it makes sense. So this is definitely one, just to be clear. You're watching this live. I don't know the answer off my head, so in those cases, I'm not in explanation mode quite yet, but I'm still trying to. I'm in the working out mode for now. Mm. So the thing that I'm thinking about in my head is that um, the thing that I'm thinking in my head is just that it is n square, or not n square. I guess it's just, let's say this is n and this is m. Then it's n times m times 2 or something like that. And I was just trying to think whether, like I can do it top down or bottoms up or whatever. So I'm gonna try to do this top down, and then we will see if it's fast enough. To be honest, I'm a little bit skeptical that it is going to be too slow. I mean, I think the n square complexity will be fast enough, but especially in Python, there are a lot of there's a lot of uh, there's just a lot of overhead with recursion and function calls and stuff like this, was what I was gonna say. So it's later in the day. I'm a little bit tired, so my apologies. If or I also hope that you watch it on like maybe a little bit faster, like 1.5x or something like that. Okay, so basically there's gonna be two things, right, that we can do. Um, eh, how do I say this in a good way? Let me think about this, right? So what are my states? I mean, I'm trying to think about the cleanest way to write the states. So the naive state is just, index 1, index 2, where index 1 is the trying to find a number to put in R1, right? Index 1. So that part, if we do it in a naive way, it's going to add another O of n. So that's why I'm trying to think about not. But maybe I don't know how to do this. Dun, dun, dun. Because I guess there are two scenarios that I was thinking about. An index 2 is just, all numbers up to index 2 is used or something. And the idea is that there are only two cases. One is that the last number or one of index is used from A1, or it is used from A2, right? Meaning that let's say we have something like, we have something like this, and we're on index say 2, then we want to see, and R1 is just say, I don't know, it doesn't really matter, but that we replace it with this number instead, right? Or something like that. Yeah. Then, we replace it with that, then the next number and stuff like that, we have to check with that number. I think that's the problem. Okay. And I think I have an idea. Let's kind of play around with this by exploring the code. I might be very wrong on this though. So definitely watch it on a faster speed if you're kind of, I don't know. But But let's think about this. So I'm going to have a couple of functions, but let's just say make increase. So this is index 1, index 2. So this is just a base case of what we had here actually. Right. Okay. The problem is also okay. Maybe I'll just set up infinity real quick. Okay. The last number used is R1 of index 1 minus 1. So that's what this assumption is for this function. I know that that's not all the assumptions, but we'll go over that for now, right? So yeah. Okay, if index 1 is equal to n, then we can return 0. So we said n is equal to length of R1, m is equal to length of R2. Actually, let's just go at L1, L2, actually, just to keep it consistent. Well, not consistent, but easier to remember which one's which. Okay. Otherwise, best is equal to infinity, and then we return best. So now the last number is let's get the previous number. If index 1 is equal to 0, then previous number is equal to negative infinity. Else, or maybe I write something like this instead. Is greater than minus 1 is greater than 0. Then this is equal to R1 of index 1 minus 1. Okay. So then now we have a choice, right? If R1 of index 1 is greater than previous, then we're already okay. I mean, we may not make this move, but it is a possible move that we make, right? Which is that we just go to the next number, right? And then here we can, the other move that we can do is let's consider the other way. So this is basically saying let's use another number from R1, right? And then we go to the next index. Here, what this is saying is we don't want to use R2 of index 2, but we want to consider a bigger number, right? So the idea here, and I don't think I made this explicit yet, is I kind of hinted at it, but I don't think I made it explicit, is that for this R2, if you use a number, and all the numbers it is and smaller cannot be used in the future because now you're getting bigger, right? So that's why we're able to do this move. We're going to consider a bigger number. So yeah, so this is basically, it's that if we want to use a bigger number, I don't know if this is necessary, but it is exhaustive-ish, but it just costs us all 1, so why not, right? And then now we want to use R2 of index 2 if R2 of index 2 is greater than previous, then we can use it as well, right? But this is a different one, right? Why? We'll see. We'll show you. My thingy is a little bit terrible, but wait. Previous to index 2 is used. Okay. And this is, let me also add some if statement here to make sure we don't go out of bounds. Typing index 2 plus, if index is less than L2, then we could do this. Otherwise, there's no more number to consider anyway. guess I can move this into that if statement, but it's fine, right? Yeah, and now I have maybe this is using max increase from 2. I don't know. Naming is tough, but but bear with me for a second. So what is this function that I'm trying to do here, right? Is that this is the same idea, but for index 1 and index 2, but the last number you used is R sub 2 of index 2 minus 1. Yeah, so that's basically why we do it plus 1, because we used this number, and then that would give us the answer. Okay, so then now this is index 1, index 2. Oh, and this is this plus 1. That's the move that I forgot, or one, just in general, I just forgot, because now this costs 1 move, right? Yeah. Okay, so then if index 1 is equal to L1, we return 0. Do we do anything about index 2? No, I think we're okay. So this is the same-ish idea that we had before. And then now, yeah, if index 2, no, this should always exist just by definition, I think. Yeah, so previous should be R2 of index 2 minus 1, as we talked about. If R1 of index 1 is greater than previous, then we can you know, just, yeah, same as before. We use it from another one. So let's just do no comment. Increase index 1 plus 1 index 2. And I know that you don't need to separate it out into 2 function, but I just wanted to make it clear for learning purposes. Yeah, so L2 then. Actually, I guess that's really it. I think in the sense that I think we can actually copy and paste this, because I think this is the same. So maybe we can reduce this a little bit. And maybe we'll talk about how to reduce this in a little bit. But yeah, and then at the very end we just return make increase. Oh, this part may not be right there. Is this right? Maybe that's right. Maybe that's fine. Actually, no. This one's not fine, because now it changes the assumption, even though that's the last number and we haven't replaced that number. I think we can be. I think the only part, yeah, I think we can do this instead. Okay. From 2, index 1, but then now this is a little bit awkward, because it assumes that we replaced it with a bigger number, but this is always going to be true, so I think that's okay. But I don't know that this is necessary, but let me just comment it out for now. So maybe they're not the same, but okay. So this is 0, 0. All right, let's run it real quick. I know that I haven't memorized it yet. I might not do the memorization explanation today, but well, I mean, that seems right then, right? Because I forgot to handle the infinity case, but yeah. All right, I'm not gonna lie, today I am very tired, as you can see from my voice. I am just going to do the lazy caching. This is functools.cache. It basically allowed me to do memorization based on this. Let me just give it a submit to see if this works, just as a YOLO. I'm only worried about the timing, so that's why well, maybe other stuff as well. So let's give a quick submit to see. This is just me being lazy on the submit. So this could be wrong and it could be time limit exceeded. But if it's time limited, it's more on the Python on Leetcode. Because if it time limits, that means that the algorithm is right, which I'm happy about. But, okay. That's not the case though, so we'll have to kind of look at the debugging here. This is going to be an annoying one to debug though. Genesis 8. What if I do use this? Okay, so I guess we. Oh, I was thinking about this, but I didn't have a case to test it. The reason why I needed something like this, though, I wasn't sure that, like, I thought maybe there's another way I could do it. But the reason why I was thinking about it, which is, so one, I know that sometimes when you watch these videos, I'm always like, oh, I thought about this, and and maybe everyone who pretends to be smart or whatever, they're like, oh, I knew it all along. Of course, I knew it all along, right? And you may think that about me, and that's fine. But the reason why I am able to debug it so quickly is because I did think about it, but I'm just. I think, to be honest, I'm a little bit older than I used to be, and I thought about it and then I forgot about it immediately. But that's also why when I get the wrong answer, and I'm able to identify why that's the case, and also I know the test case for which this is wrong. I mean, this is a case where it's wrong, but the reason why this is wrong is also because in this input, they're duplicate numbers, right? So all two could be, let's say in an extreme case like 1 1 1 1 1 2 3 4 5 6 7. If we used one of the ones, we get stuck. Is why, because then, and we want to use the two next, say, for whatever reason. Let's say we have 100 or 1,000, 999, and then, like, I don't know, 3 4 5 6 7, right? In this case, you want to change 1 and a 2. I think the answer is obvious, but because of the way that this is constructed, I'll stuck at the second one, because the second one would never be bigger than the first one. So that's why so that's why I got this wrong answer. And also, as soon as I uncommented it, it bugged it. But I thought that the way that I did it is a little bit inefficient and a little bit sketch. That's why I commented out, but I kind of forgot about it and I YOLO submitted. So whoops. But I did think about it, and that's, or at least I thought about, I knew that I needed to take care of this case, but then I just forgot about taking care of this case, which is why I was sad. I was like, I should have known better, because that's what I was thinking about it. Okay, so at least now we know that we're right, except for that, let's take a look. 20 of 21. Okay, so we know that we're right, or at least I mean, technically, anyway. I mean, I guess technically you could also be wrong on a later case, but like a regular WA for a later case. But at least we know that we're functionally right, and we can do some optimizations here. And to be honest, this is n square. We want to do the analysis. This is going to be n square time, n square space, and really should be fast enough. But Python is just, or Leetcode Python is always a little bit yucky. And to be honest, I'm a little bit, this isn't the most things. And I also find that cache for multiple parameters is a little bit expensive. So first of all, maybe I shouldn't have been lazy, but I just wanted to check the correctness more than that. I want to check the timing. If I need to do it, I need to do it. But so let's say we have, I was just looking at this, and I think I could combine both of these functions into one function. It's very similar, but I think for learning purposes, for your learning purposes, so maybe I need to learn a little bit too. I'm just going to do it this way. And I know that it's very tempting to put it in a dictionary, but one is, if you have a TLE, a dictionary is just on a tuple or something like this. It's just slow on tuples in general. it is what it is after a certain point. So you actually want a two-dimensional array for that reason. So yeah, let me is it +1 or +2? Because this can be L2. So okay, yeah. And you know, if you've been a watcher of this channel, and if you're not, you should hit the subscribe button. You know, this is a standard way that I write this. For you know, it's pretty straightforward. If it has cache of the inputs, then we return the cache. Right? Otherwise, you know, we do the actual work and then we cache it. If this is still too slow, I'll just write it tops down. I think that should be good. I mean, you know, like we will see. I don't know. I mean, right now we're optimizing. Right now we're optimizing. Oh, there's a typo here. Mostly because we have two of these. Yeah, we're optimizing some constants. So like, you know, yeah. Yeah, we'll see if this is that much faster. I guess I could actually, let's see. Yeah, so like this is still gonna be n squared, and it doesn't really change. It makes it faster for sure, but how much faster I don't know. So yeah, like it may be 1 or 2x faster or something, right? And you know, is that fast enough to submit? Well, at least now we have a test case, and it takes 7 seconds to run. But there are other inputs, right? So that's why this is, you know, a little bit sad. I don't know how. Maybe I should have had. Oh, I forgot to take out the cache, so that's why it is. You know, now it's doing both those things. So, or at least in that one. Let's run it again real quick. See if that's faster. It should be faster. Well, maybe it should be slightly faster, but I don't know if it's just fast enough. All right, let's give it YOLO. If I wasn't lazy, I would have did a comparison to see how much faster we are from the cache version. But I'm okay with just like eating a TLU. You know, it's not really that serious. Okay, still TLU. Okay, this is very sad, but okay. So then now we can write it bottoms up, right? Yeah, I think the tricky thing about the way that I did bottoms up is that I kind of did this one in a funky way, but otherwise I think this is fine. Yeah, I mean, I think we just have to do a bottoms up. So that's kind of, and I know that I could combine them and do again one function, but I'm still gonna let's just do 2 of these so that it's a little bit fun to do the dynamic programming. Right, just yeah. Well, let's go at DP because I'm lazy, and let's just say this is 0. Right. No, wait, we want this to be infinity, and then we want the base case is. You can write the base case in a little bit different cases. For me, I actually do struggle. I mean, because now I have to think either think backwards or whatever. In this case, the problem is symmetric, but you know, for if you want to translate tops down to bottoms up, you know, I want to keep it as faithful as possible. So yeah. So then now for index 1 in range of from L1 yeah, from, is it from L1? Yeah, from, well, L1 minus 1 to 0 2 in range of, I'm just double check. What I'm doing now is I'm looking at these to make sure that I'm doing this in the right order. I'm actually not quite certain which actually not quite certain which I guess the other optimization I could do is get rid of the mins. I forgot about that, but I don't know if this is gonna be fast enough, so I might as well get a little bit more practice on bottoms up. I'm also just thinking, making sure that this is actually good enough. But of course, sharp eye people might notice that I actually need 2 of these, and you're right. The naming is terrible, but it's terrible in a standard way, so that makes it a little bit better. Maybe not, but and one thing that we have to do is set up the base case, and my base case here is actually L1, right? So index 1 is equal to L1, so dynamic set for index 2 in range of L2 minus 1 minus 1 dp of L1 index 2 is equal to 0, and dp2 of this as well. Okay, and then now we just have to kind of copy this code really. We go, and away we go. Oh, I guess previous is equal to array 1 of index 1 minus 1, and okay, fine, I have to do this like logic. Okay, so best now is dp of index 1 index 2. I might have to get rid of those min statements too, but we'll cross that bridge when we get there. I'm keeping in. Sorry, friends, if this is a little quiet. I mean, right now I'm just literally copying line for line and from this code, so that's basically what I'm doing. dp2 plus 1. Okay, that's basically this code, and then we also might as well just put in. So this is for dp1. So we almost might as well doing it I think we have to do it simultaneously actually, otherwise the thing is not filled correctly. So yeah, now doing the other one. So previous 2 is your index 2 minus 1, right? And then this is where if R2, oops. I missed the, okay. Let's see. And this is just all about being careful, really. and not making a typo, which you can see that it's very easy to if you're not careful. Man, for a problem I know how to figured it out. There's a lot of there's a lot of work to get it right. Okay. I probably could have written this another way, but oh well. Okay. And then now it should be just dp00. I don't know that this is transcribed right. The algorithm, or at least the original one, should be right, but whether this is right is another story. It's because it's easy to make mistakes. I hope I don't, and I hope that this is fast enough. But okay, so I got most of. I mean, it looks okay. What am I missing? I'm getting a -1 on here. So maybe I do have a typo, because I am getting the big. Wow, this is actually slow too. So this is not even that much faster. Really? Wow. Huh. Is there a faster way? Maybe it's just the min functions. Yeah, this is actually slower than before, to be honest. And more incorrect, I suppose, but that part we can fix. Let's see. I think this part is... No, this part's right. Yeah, this part should be right. Let's see. Did I miss a case? I mean, the code should be the same. I already deleted it, so... Let's see. And all these depend on the previous one. This one's a little bit dubious, actually. Now we do them in the right order, so this should be okay, unless I'm... Oh, I see. Maybe. Oh yeah. This should be out too. That's why. Because we don't update it. I mean, that's one of the examples. I don't know if this is the only thing. And also, we're still running into speed issues. Is it because of the 6 minutes? Okay, well that's... that was definitely an issue. I mean, and obviously it's going to be slower because you have one more loop, but... Oh, I think I have to set this one as well. To set the base case. We didn't set the base case here. So that's going to be a little bit yikes. Because the thing you can do is with, you could do space optimization stuff as well. Or is it wrong though? We'll try again. Maybe I think we were close, but I mean, I'm worried about the correctness more than the time limit exceeded. That's why I guess I could remove some of the smaller cases. Okay, so now we fixed it. Okay, I just want, because I thought most of the, because I was looking at my conditionals and that looks okay, but that's a little yikes, man. Because the thing is, if I did this in another language, I'm relatively confident about it. I think I have to get rid of the mints, but what a dubious thing to get rid of. That's what I mean by Leetcode is sometimes, not great in that regard. I should keep it consistent. Fine. I did it this way earlier. Because we kind of, I kind of do want to just explain the problem, but I think I've explained it okay by coding it. But right now we've spent about 20 minutes just optimizing optimizing what we already know, right? So that's a little crappy, or like, it's not that interesting, right? I'm not learning, you're not learning, you're bored. I don't even know what to say other than being sad about it. I know that I didn't do the other half. I just want to see if it makes a measurable difference. Some of it is because minutes of function call in Python overhead, and we're doing 4 million of them. In a problem, it's a lot. It is faster, but not so fast. So I mean, okay, I guess it is what it is. I'm gonna submit this just so I have it on my submission. I know that this is gonna time out, and the reason why is I'm just gonna do it in C++, just to get it done. But yeah, okay, thanks. I'm just thinking about it for a second, but yeah, I mean, oh, that's some weird windows up. Yeah, I mean, I think I'm just gonna come with the C++. There's no, not trying to do anything. So this is just so silly. I think 10,000 is actually good because you can only do 4,000 anyway, right? Or 2,000, I mean. Okay. Let's forget how this goes. Okay. Making sure about syntax, mostly because it's been a while for Python and stuff like, for C++ and stuff. I sometimes will double check. I will double check that that I got it correctly. Need more real estate. Okay. I mean, sorry friends if you're watching this. If you are watching me saying these exact words right now, what am I doing? Yeah, let me know what you think about the show Westworld. I actually just finished watching the season finale. It's very intense. Let me know what you think, and I'll give you some props in my head or something. I don't know, because this is like 40 minutes into a random problem. So, yeah. Oops. Okay. I guess it just has to be -1, really, so that's fine. If this times out, I'm gonna be very sad though, by the way. So I really hope it doesn't. I think this part literally is copy and paste. Well, mostly, kind of. Yeah. Obviously not actually, but just save me some typing. I'm gonna get this wrong, but that's fine. I guess I should just copy this part out instead of keep going down. Okay. Do. Okay, I think this is okay. I mean, it's not okay yet, but I just want to make sure I don't have any typos or anything weird. And see if this is fast enough. 198? That's actually, I mean, look at this. For this, I mean, I know they have to do more work, but look at this. That is so fast. Come on. Come on. Right. Okay. Come on, friends. But yeah, whenever you hear me complain about, just to give you a little bit of a comparison, that went for 8 seconds on that went for 8 seconds on Python. So anytime you hear me complain about C++, well, not C++, but like that I should have done in C++, this is why. Actually this one. But oops. But yeah. What? Oh, oops. But yeah, this is kind of annoying because, and I don't know when I started it, but oh jeez, I'm very lazy to look at this part. That's why. Because this was about half an hour ago. So I got it. Oh no, not this one, but still, this one I got it mostly right half an hour ago, and I'm just, oh my god, Larry. I'm just been, but yeah, half an hour just trying to get the constants right. So that's a little bit sad. Okay, we do run into some issues though, so maybe I am wrong. Unsigned offset. Do they not tell you where it is? Do we overflow? We shouldn't overflow. We don't really do anything. Right? can't tell if this is like do we look at the wrong thing? And also, how does this not like have an issue in Python? That's the one thing about Python that's a little bit scary, is that I sometimes do get it wrong. I guess that makes sense because I do have index +1 here. Well, that's why I have index +2. Where am I going out of bounds? Is it just here? Alright, let's see. I don't think I overfolded like one character, so there's some weird typo about this then. Index 1 +1, right? Why is that an awkward thing? Or maybe it's this one. Oh, well, this is definitely a thing. Why wasn't that an issue earlier? Oh, because in the recursive function, yeah, it's a little bit different. Because in the recursive function, you cannot get to the recursive function unless, so yeah, so okay, so maybe I should just do this. I think that's fine, because you can, dp2 might not have any right answers for index 2 is equal to 0, because we assume that index 2 minus 1 is a thing. And also, I forget what language I'm in, but only in a weird way. Okay, so it still takes quite a bit of time, but we'll see. Let's see. But 10 times faster than the Python version, and also some AC on the first go. I don't know if I could have done it recursively. Maybe I still need to make this optimization, but as you can see, it is just ridiculous, right? And it took me 10 minutes to convert the code. Maybe that's a little bit slow, but nonetheless, this is also this one, the way that I did it has a lot of typing, I guess. And just typing index 1 and 2 is a little bit bad. Yeah, so the complexity, as you can see here, let me scroll down a little bit so you can see all my code. Is just that, yeah, the space and the time should be pretty straightforward, right? We just have all of one operations on each of the everything inside, and on the outside it's L1 times L2 or n times m. Same here. There's a sorting, of course, so technically the time is going to be O of n times m plus m log m, so if you have a small n or something, and space is going to be O of n times m. So yeah, that's pretty much all I have for this one. Let me know what you think. It's very tiring because, you know, I basically lost literally half an hour, you know, just optimizing it because Leetcode is a little bit silly. So yeah, that's what I have. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. I'm really tired. I don't know. If you do have any questions, I know that I cut this a little bit short, but if you do have questions, come to the Discord, leave a comment on the channel. You know, you are seeing this live, so but come hang out. We'll ask questions. Hope you did it today. This one was annoying as F, so I'll see you later. Anyway, like I was saying, I don't even know anymore. To good health, to good mental health. I'll see you later and take care. Bye bye.